Hello and welcome to the Unit 7 Section 2 video on rational exponents. So in the last section we talked all about exponents and how you can work with them and everything. Now we're going to take a look at what if the exponents were fractions, okay? And that's going to be related to roots. So let's start off this section by talking about what roots are, okay? So the radical symbol is used to indicate roots. And we've got three parts to it. You have the variable or the number that's inside the root symbol, which is a radicand, the root symbol itself, which we call the radical, and then you have a number on the outside, which is the index. So to recap, the index is a small number to the left of the radical symbol that tells you which root to take. The radicand is the expression under the radical symbol, and the radical symbol is used alone to indicate a square root or with an index to indicate an nth root. So for example, if you had a 3 as your index, it would be the cube root. Since 2 to the third equals 2 times 2 times 2, which also equals 8, then the cube root of 8 equals 2. So it's basically the opposite operation of taking something to a power. So another way to write nth roots is by using exponents that are fractions. For example, for b is greater than 1, let's suppose that the square root of b is equal to b to the k. All right? Well, if I square both sides, then the square root of b squared just gives me b to the first power. And on the right-hand side, b to the k to the second, we multiply those exponents using the power of power rule. And you've got b to the first equals b to the 2k. Well, since we have things with the same base, we can set those exponents equal to each other. You have 1 equals 2k, and if we divide each side by 2, you get k is 1/2. So k to the, or b to the 1/2 power is the same as the square root of b. So that brings us to the definition of b to the 1 over n. A number raised to the power of 1 over n is equal to the nth root of that number. So for example, 3 to the 1/2 is the square root of 3. 5 to the 1/4 is the same as the fourth root of 5. 2 to the 1/7 is the same as the seventh root of 2. Okay? So let's convert each radical form and simplify if possible for a through d here. So for a to the 8 to the 1/3, that's going to be the cube root of 8, which happens to be 2. You can do the cube root of 8 because 2 times 2 times 2 is 8. For b, x to the 1/3 is simply the cube root of x. For c, we got to take x and y both to the 1/5 power, so we take both to the 5th root. Okay, so the 5th root of xy. For d, you've got the square root of 16y, because 16y to the 1/2 is the same as the square root of 16y. And you can take the square root of 16 and bring that to the outside. So 4 square root of y would be your simplified form of d. Now let's talk about simplifying expressions with fractional exponents. Okay, a fractional exponent can have a numerator other than 1, as in the expression b to the 2/3. You can write the exponent as a product in two different ways. So in the first way, we are going to write it as b to the 1/3 times 2. Okay, we kind of reverse the product rule here and split up our fraction. Numerator is one part of our product, and the denominator is our other part of our product. Well, b to the 1/3 squared is what we end up with here, because when you're multiplying exponents, you're taking power to a power. B to the 1/3 is the cube root of b. So you could do the cube root of b quantity squared. Let's take a look at it another way. So if we have b to the 2/3, we could split it up with the 2 out in front. So 2 times 1/3, which would give us b squared to the 1/3, which would be the cube root of b squared. So you could do it either way. You could either put the numerator on the outside of the radical, or you can put it on the inside of the radical. And that's basically what the definition of b to the m over n tells us. So I'll let you read that for yourself in your notes. Let's work with it. So in example 2, convert each to a radical form and simplify if possible. So for a, we have 8 to the 2/3. We are going to write that as the cube root of 8 squared. 8 squared is 64, so we have the cube root of 64, which happens to be 4, because 4 times 4 times 4 gives us 64. For 2x to the 2/3, we can rewrite that as the cube root of 2x quantity squared. Okay, you've got to put the parentheses around. Then we can do 2x squared, that gives us 4x squared. And that simplifies that. For c, we can take the fourth root of 4xy to the third, all to the third power. Now, I forgot to put the negative in there, so there's still a negative in front of that 4, so keep that in mind. We take it to the third power. In fact, let's take that negative off of the front here, okay? So remove that negative from in front of the 4. Let's just do this without the negative. So we've got 64, x to the third, y to the ninth, and that's it. That's as far as you can go with it. For d, we're going to take the square root of 4x to the fourth quantity to the third, and then we're going to take 4 to the third power, and then use the power rule. 4 times 3 gives us 12, so x to the 12th. So we got the square root of 64, x to the 12th. Square root of 64 is 8. Square root of x to the 12th is x to the 6th. Now, it may be easier to use the properties of exponents to simplify expressions. So we're going to do that in these last two examples. So we're going to convert the cube root of x to the ninth, y to the third, to x to the ninth times y to the third, all to the 1/3 power. Here, we can apply our power to a power. So we're going to multiply the exponents. Okay. First, we'll split up. We have our x, we have our y, and then we do our power to a power, which means we multiply the exponents. And that's going to give us x to the third, y to the first, which is x to the third y. For b, we're going to leave that front term alone. And then the third root, or the cube root, of y to the third is just y. Now we're going to take power to a power. We'll split up our x's and y's in the first term, multiply our powers, and get x to the 8th, y squared. We will do our product rule for our y terms, so y to the 2 plus 1, so we end up with x to the 8th, y to the third. So now that we know how to work with exponents, this is going to be very important information to know, because moving on into the next unit, we're going to start working with quadratic functions. And when we work with quadratic functions, we're going to have to be able to work with exponents. So hopefully in this unit, you will have gotten all of the exponent rules down to where you know how to work with exponents when we have to work with them in other units. All right, that finishes off this section and this unit on exponents.